Hello everyone, it's July 2016 and Pokemon Go is everywhere. Catching Pokemon is a big deal. I tried it myself. Now I don't know much about Pokemon, but I did notice something when I started to tap on each Pokemon. There are some metric measurements in there and I thought, what could we do with those? Maybe we could investigate what these Pokemon would look like in the real world. I mean, after all, we're supposed to be capturing the Pokemon in our world, aren't we? But you might be saying, wait a minute, Pokemon aren't even real. Why waste our time studying something that is fake? Well, I think there are plenty of fake things out there that inspired people to start exploring real science.
Hello, computer.
How can I be of service, detectives?
Besides, how realistic are some of the density worksheets that wind up in our students' hands? A block of copper? I'm pretty sure that our students probably saw a lot more Weedles this summer than a giant block of copper. So, how might you start this project? Well, first, pick a Pokemon and try to estimate their volume. You're given the height in the app, and you can just match up your Pokemon to a certain shape and find the volume of that shape. I chose Ghastly because he's a sphere, and spheres are easy. Volume of a sphere is easy to find. But for other Pokemon, your students might have to use other shapes or combinations of shapes to find the volume. Next up is the density calculation. Good old mass divided by volume. Again, I started looking in the app for where we could find the mass for each Pokemon, but you should know that there are other sources for this information. Like, try the official Pokemon Pokédex. I switched the country to the UK so we can get metric measurements, and they have everything you need about all the Pokemon. Another place, which is one of my favorite websites, is Wolfram Alpha. They have a database of Pokemon information. And the nice thing about that website is it will also be an excellent place for students to get help confirming their calculations. Once your students have their density and volume, it's time for them to start describing how their Pokemon might look and behave in our real world. Like things like, what does its mass compare to? What does its density compare to? Would it float in water? Heck, I mean, your class could even make a Pokemon density tower. I put together some slides for all of this and a worksheet that you and your students can use to get started. You can find links to download it in the description of this video. By the way, I'm definitely not the only one who's been looking at the measurements of Pokemon. It's been going on for a long time. I found a message board about Wailord, which is this big Pokemon, and it goes back 8 years ago. There's a couple blog posts about the fact that this thing's density would be lighter than air. I found a YouTuber who did a nice presentation on the whole topic. He also has a whole playlist of strange Pokemon physics. You can see some familiar things there if you are a physics teacher. I'll put links to that in the description. Well, that's it for the Pokemon calculations video. If you liked it, please give it a thumbs up. That helps me out. If you have things that you've done with Pokemon in your classroom or you intend to do, share those in the comments. I think that's huge for teachers to be able to read whether people are starting to think about and those kinds of things and how they're going to use it for lessons. I have done a couple other videos on comparing fiction and real life in movies and videos. Most of them are about looking at the density of gold. There's some measurements and resources involved. I'll put the links below. If you like what you see, please subscribe to my channel. Thanks much.